So today we'll be looking at solving simultaneously. So we have two equations and we need to solve them. Solve them means we need to get an answer for x and y. So we have been familiar with solving equations like this. 3x minus 1 is 4. So 3x is equal to, taking minus 1, carry it across, you'll get plus 1. 3x is equal to 5. Right? Then we can divide both sides by 3 and we'll get x is equal to 5 on 3. So it's easy for us to solve equations of this nature. Problem now develops when we have equations with an extra variable, y. So these equations have x and y in it. So the objective is to eliminate one of the variables, eliminate x or y. So how do we do that? It's very simple. All we need to do is to make these values the same. So for example, if I call this equation 1 and equation 2, let's say I take equation 1 and I multiply by the number 4. So I'll get every value, right? Don't forget it's always every value. 2 by 4 is 8x, 2 by y is 4y, right? And 4 by 5 is 20. This becomes my new equation. If you look carefully, these two equations have these values basically the same. So let's see. I have 3x minus 4y is 2. This is my equation 2. So my objective is to find a way to get rid of y, get rid of x. Here's what I have. I have plus 4y and minus 4y. If I were to add these two equations, what will happen? Let's say I were to add equation 2, 3 and equation 2. 8x plus 3x is 11x. 4y plus minus 4y is 0. And 20 plus 2 is 22. So what I was able to do in this method here was to multiply this equation by a number, get these two almost the same, well, same except the sign, and eliminate by either adding or subtracting the equations. And that's the principle behind the elimination method. So I multiplied it by 4. These two values have opposite signs. Whenever it's opposite signs, you add. When it's the same signs, you subtract. So in this case, I have opposite signs, so I add everything. And here, I divide both sides by 11, and I'll get x is equal to 22 divided by 11, which is 2. Okay? But I'm not done. Remember, I have two equations. So I can say now, from equation 1, when x is equal to 2, okay, I will have 2, so x is 2, remember, plus y is equal to 5. So I'll have 4 plus y is 5. So y is equal to 5 minus 4, so y is 1. And the answer written like this, x is 2 and y is 1. So that's the way you solve simultaneously using the elimination method. Follow? So the elimination method removes x or y. It could also have been done by multiplying by x. Okay? So I could have multiplied this by 3 and this by 2 and then subtract them. Same principle, I would have gotten rid of the x and I solve for the y and then go and solve for x. Follow? So this is the elimination method. Let's do it a different way. Let's see if we can do it now with the substitution. So let's see if we can do it the substitution method. Same principle. The principle is to, very good, to eliminate one of the variables. Let's see now, from equation 1, I say, okay, I want to eliminate y. So I'm going to make y the subject of the formula. So, from equation 1, 2x plus y is 5, carry across positive 2x, it becomes negative 2x. So y is equal to 5 minus 2x. Simple. This is my equation 3. So since I know what y is, why don't I just replace this y with this y, and I will have no more y. Understand why? Okay. So substitute equation 3 in equation 2. So I'll end up with 3x, remember I know what y is, minus 4 by 5 minus 2x is equal to 2. So I'm going to expand out this. So I'll get 3x minus 4 plus 5 is minus 20. Minus 4 by minus 2 is plus 8x equal to 2. Keep my numbers on one side, keep my variables on one side and my numbers on one side. 3x plus 8x is minus 20 becomes positive 20. 3x plus 8x is 11x. 2 plus 20 is 22. X is 22 divided by 11. X is 2. Similarly, x is 2. So from equation, this is the easiest equation to use because I already know y. From equation 3, y is equal to 5 minus 2 by 2. Y is equal to 5 minus 4, which is 1. And we have our answer. Our answer is 2, 1. Simple. So we have an example here of elimination method and now substitution method. I hope it becomes easier.